Alright, so in this video we're going to be talking about different inequalities. Now, we briefly touched on inequalities in our pre-algebra section. But in this video we're going to go a little bit more in depth and we're going to talk about compound inequalities. Then we're going to also talk about inequalities containing absolute value. And we're going to talk about how to solve equations that are inequalities. So let's go ahead and talk about what is a compound inequality. So if you remember, an inequality is like an equation. So if we had the equation x plus 2 equals 4, that would be our equation. Now, an inequality would be something like x plus 2 is greater than 4, or greater than or equal to 4, something like that. So this is what determines that it's an inequality, if something's greater than, equal to, greater than or equal to, less than or equal to. So a compound inequality is when you have an inequality that has two sides to it. So if we've got our x plus 2, and that is less than or equal to 10, but also x plus 2 is greater than 6. So as you can see, that there are two values now that are being related to this inside x plus 2 value. So you're going to solve this just like you would any regular inequality, but anything that you do to the middle, you need to do to both sides. So whereas before we just had one side of our inequality, so if you would just do your operations to both sides, now we're going to do it to all three sections. So for example, we need to isolate x right here. So we're going to subtract 2 to get x all alone. And again, whatever you do to the middle section, you got to do to both outside sections. So 6 minus 2 is going to be 4. Your inequality symbols are going to stay the same. So less than x, which is less than or equal to 10 minus 2 is 8. So that right there is going to be your solution to that inequality. And you can go ahead and graph that on a number line in the same way that we graphed our other inequalities. So we're just going to go ahead and draw our number line here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, now at 4, we're going to have an open circle, right? Because it's less than, right? And then at 8, we're going to have our closed circle because it's less than or equal to. So open at 4 and closed at 8. Now again, if we look at 4, we just look at this section right here, we can see that x is greater than 4. All right, so x, we're going to go to the right because it's greater than 4. Now, if we look at just this section now, we can see that x is less than or equal to 8. So at 8, we're going to go to the left here. So as you can see, these arrows are going in towards each other. So we're just going to fill in the space between them. And that's the solution to that. Now, another form of a compound inequality might be something like this, where you've got x plus 2 is greater than 10, or x plus 2 is less than or equal to 6. Now you're just going to solve these individually and then we'll graph them at the end. So minus 2, x is greater than 8. Minus 2, x is less than or equal to 4. All right, so then you draw your number line. Got 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, we've got an open circle at 8, a closed circle at 4. Now if we look at this, x is greater than 8, so we're going to go to the right at 8. And then look over here, x is less than or equal to 4, so less than, we go to the left. So we'll fill in those directions, and your solution will look like that. All right, so now let's talk a little bit about absolute value. Again, we briefly touched on absolute values in our pre-algebra section, but we now want to be able to solve equations and inequalities that contain absolute values. So let's go ahead and look at equations first, and then we'll move into inequalities. So if we had the equation, the absolute value of x minus 3 is equal to 3, this absolute value in here means that whatever is going on in here, you're going to take the positive version of that value. So in order to get there, you're going to split this here into two different equations to get rid of your absolute value sign. And so how you're going to do that, you're going to go x minus 3 is equal to positive 3, and x minus 3 is equal to the opposite of this value here, so negative 3. All right, and then you're just going to solve those individually. So x equals 6 plus 3 plus 3, x equals 0. All right, and that would be your solution to that equation. Now, as you can see, that works because if you come back down and you plug in your solution, so if we plug in x equals 6, you get the absolute value of 6 minus 3 equals 3. 6 minus 3 is 3. You take the absolute value of that, and you get 3 equals 3, so that works out. Now, if we plug in 0, we're going to get 0 minus 3. Take the absolute value of that, that equals 3. So that's the absolute value of negative 3 equals 3. Now, the absolute value of negative 3 is 3, so that works out as well. So now if we look at this with inequalities now instead of equations, if we look at something like x minus 1 plus 6 is greater than or equal to 14. The first thing you're going to want to do is isolate your absolute value. So you're going to want to think of this as a group, and you're going to want to get that on one side of the inequality and everything else on the other side. So we're going to go ahead and minus 6 from both sides, and we'll get the absolute value of x minus 1 is greater than or equal to 8. All right. Now that we have this here, we can go ahead and split into two equations to remove our absolute values. So this is going to end up being equal to x minus 1 is greater than or equal to 8, and x minus 1 and negative 8. Now with inequalities, when you apply the negative to your second inequality, you also flip your inequality sign. All right, that's really important that you get that direction on your inequality correct. All right, and then you just go ahead and do the same thing that we were doing with our equations. You're going to add 1 to both sides, so x is greater than or equal to 9. Add 1, add 1. X is less than or equal to -7. Now you can come down here. You can graph that on your number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. All right, now there's going to be closed circles on both of these. Now looking at this, x is greater than, so we're going to go to the right. X is less than, so we go to the left at -7. And so this here would be your solution to that inequality. And it's really simple as that. So that's all we've got for compound inequalities. We talked about absolute values in equations, and then we talked about how to solve inequalities in equations that contain absolute values.